Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. Subscribe and share widely so that we can work together. And we continue to explain something in Pure Mathematics 4. And still in topic number 2, partial fractions, and we want to explain something like in example 3. But before then, let us understand something that is on page 10. And previously we have learned how to express a fraction, a general expression in partial fractions, whereby we separate the terms and write them in terms of a over something plus b over a certain linear function plus c over a certain linear function. But in this case, we are being told that a single fraction with a repeated linear factor in the denominator can be split into two or more separate fractions. And in this case, there is a special method for dealing with the repeated linear factor. Of course, it goes without saying, for example, if you're talking about 2x plus 9 all over x minus 5 and then x plus 3, and this is the linear factor which is squared, it's repeated. This is a linear factor which is just a dependent. This is another linear factor which is the repeated one, and this is now the subtopic. We can write it in terms of, please remember that the denominator contains three linear factors, which is x minus 5, x plus 3, and x plus 3. Note that x plus 3 is a repeated linear factor. And of course, it goes without saying, and because there are three linear factors, we just deal them as such. So we have a over x minus 5 plus b over x plus 3 plus c over x plus 3 squared. Please don't forget that. And the expression is written as the sum of the three partial fractions. Notice that x minus 5, x plus 3, and x plus 3 squared are the denominators. But let us just look at this through an example. You're going to talk about example 3. And example 3, we are taught to show that 11x squared plus 14x plus 5 all over x plus 1 squared multiplied by 2x plus 1 can be written in the form a over x plus 1 plus b over x plus 1 squared plus c all over 2x plus 1, where a, b, and c are constants to be found. Of course, it goes without saying that when you say that let the whole of this be equals to what we are suggesting, and of course a is equals to what? Plus b, a over x plus 1 plus b over x plus 1 squared plus c over 2x plus 1. That is what we have been asked to show. So you need you need denominators of this format, this other denominator, and this other denominator. So therefore, if you could talk about the whole of the LCM is going to be x plus 1 squared 2x plus 1. So when you divide by this, you get, of course, x plus 1, 2x plus 1. Because the whole of this denominator, you divide by this, you are left with x plus 1, 2x plus 1. That's what you get. And of course, when you divide by b plus b, you divide by b, you get 2x plus 1, because the denominator of b is x plus 1 squared. So the whole of this LCM or denominator divided by this, the whole of this bracket cancel out, and then we have that. So when you divide by this one, you get x plus 1 squared. You get c, or rather c plus x plus 1 squared. And all this is just equals to the numerator now. So at the end of the day, we are having something that is looking like this. 11x squared plus 14x plus 5 is exactly equals to a x plus 1, 2x plus 1 plus b 2x plus 1 plus c x plus 1 squared. And at that point, we can just try to make this bracket 0. So let x be -1. And when x is -1, so we are going to have 11 plus minus 14 plus 5. This is 16 minus 4, which is a 2. Which is a 2, being equals to what? The whole of this term is 0. The whole of this term is 0. But the whole of this term is minus 2 plus 1 minus 1. So minus b. So what is our b? Definitely b becomes minus 2. Having had that, or having said that, we may wish now to make this bracket 0, 2x plus 1. Remember, we only have two brackets to make 0. If that is not enough to make us get all the values a, b, and c, then we will compare the coefficients. We'll combine the two methods. So let x be -1/2. When x is a -1/2, a -1/2, it becomes something to do with this becomes 11/4 minus a half, becomes -7, and this becomes 5. So 11/4 minus 7 plus 5 is going to be equals to everything. Let's talk of this as 3/4. This is definitely going to be 3/4 because of 11/4 plus 5 minus 7, that is 3/4, which is equals to what? The whole of this becomes 0 because this is 0. The whole of this becomes 0 because this bracket is 0. And minus a half plus 1 is a half. A half squared is a quarter. So we are talking about a quarter C. It is a quarter C. Cross multiplication is going to give us something to do with yes, what? 4C is equals to 12, and C is by itself a 3. That is just a 3. So we have B, we have C, but we do not have A. How do we get an A? And this is now the most important part of this question. Comparing. We're bringing on board comparing the coefficients of, let's say, x squared. And when we compare the coefficient of x squared across, we have 11 is equals to, what are the coefficients of x squared here? X times 2x, which is 2x squared times a, 2a because we have 11x squared. We can talk about 2ax squared. There is no square here. Here there is a square because x squared c becomes plus c x squared. We may factor out x squared and have 11 is equals to 2a plus c. But of course we know our c is 3. Since we know our c is 3, then we can talk about 11 is equals to 2a plus a 3. And that means our 2a is equals to an 8 because of 11 minus 3. And our a is a 4. So at the end of the day, we can talk of therefore 11, let's write it again, 11x squared plus 14x plus 5 all over x plus 1 squared 2x plus 1 can be written in terms of a 4 over x plus 1 plus b, and our b is minus 2, so we have to take care there, minus 2 all over x plus 1 squared plus c, which is a 3 all over 2x plus 1. And this is what we are supposed to show, and we have been able to get the values of a. So in a nutshell, we can simply say that a is equals to 4, b is equals to minus 2, and c is equals to a 3. That way, we have been able to show exactly what we are supposed to prove. All right.